Welcome to DP360 Introduction to Hydrocarbons. Hydrocarbons plays a crucial role in our day-to-day life. They are the main component of the fuels, the LPGs, natural gas which contains 80% methane, 10% ethane, and the remaining 10% consists of a mixture of higher alkanes. The name just I have taken, the alkanes, the methanes and ethanes, all of these are different types of hydrocarbons. Not only that, hydrocarbons are very important and they are used as the starting material for polymers like polythene, polystyrene, polypropylene. They are used as solvent to make paints, dyes and life-saving drugs also made from hydrocarbon. But first thing first, what are hydrocarbons? Hydrocarbons are the organic compounds made up of carbon and hydrogen mainly. Yes, made up of carbon and hydrogen only. So these are called as your hydrocarbons. The two main classes of hydrocarbons are your open chain hydrocarbon and closed chain hydrocarbons. Let's draw a skeletal structure. SC stands for hydrocarbon. The two main classes are open chain hydrocarbons and second category is closed chain hydrocarbons. What do you understand by open chain hydrocarbon? That it consists of carbon atoms in open chain system. That is open chain hydrocarbon. Closed chain is the carbon atoms are present in closed ring-like structure. That's closed chain hydrocarbon. Again, open chain hydrocarbons are further divided into three types. Alkane. These are saturated hydrocarbon. Alkanes are the saturated hydrocarbon consisting of only single bond. Why they are called as saturated hydrocarbons? Because these compounds, the carbon atoms are saturated with hydrocarbons, crowded with hydrocarbons, crowded with hydrogen. That's why they are called as saturated hydrocarbon. Mainly they contain only single bond. Alkenes are called as unsaturated hydrocarbon and so is alkyne. It contains double bond, it contains single bond and alkyne contains triple bond. Minimum of one triple bond are present in alkyne. Now open chain hydrocarbons are further divided into two categories. They are your alicyclic hydrocarbon, alicyclic hydrocarbons and aromatic hydrocarbon. Aroma means smell, very sweet smell. So aromatic hydrocarbon means these are the compounds which gives sweet smell, fruit smell. One of them mainly these are arenes and one famous type is benzene. The formula of benzene is C6H6 and the structure of benzene is somewhere hexagonal in with alternate single and double bond or C H HC SC CH CH CH. Join them. This is your and double bond. One thing you need to be very smart, that you should always keep in mind that carbon contains 4 bonds. That's very critical. At times we do these silly mistakes in the exam, that there may be more than 4 bonds we depict in the diagram, or we draw less than 4, then we should know, we can do a self-evaluation. If we count the number of bonds present with a single carbon exceeds than 4, then you are wrong. Then you need to modify the diagram. And alicyclic, these hydrocarbons they contain close ring-like structure in which carbons are present, carbon atoms are present. One cycloalkanes, cycloalkynes, and this is alkane rather, cycloalkene and cycloalkyne. Now give some cycloalkane examples. Let's say CS2, a ring-like structure of 3, minimum of 3, S2C and CS2. So if you see the equivalent diagram, it becomes a triangle, equilateral triangle. Similarly, this is your cyclopropane. This is cyclopropane, cyclic compound. One example I have given. Now you can one more example we can make. This is called as cyclobutane, as it contains 4 carbon at the vertices of a closed ring. So therefore it is called as cyclobutane. Now if I have a triangle kind of a figure with a double bond, then it becomes cycloalkane. So this is cyclopropene, ENE, and it contains a triple bond. Cycloalkyne contains a triple bond. Now alkane and alkyne will pay more focus on alkane, the one of the most important open chain hydrocarbon is alkane. So if we know the nomenclature of alkane, because one thing, the IUPAC system of nomenclature is more or less consistent. If we understand it for a particular compound, then the rule remains same for others for nomenclature. And nomenclature seriously play a very crucial role so that your fundas should be spot on. Many people falter, they cannot just name it, they miss out on the commas, on the hyphens, the number, the ligands where they are exactly, the substituent position, the main chain, but rest all your worries, be happy, be delighted. The rules are very simple. I'll explain it in the best possible manner so that the things you can imbibe it permanently and use it at the right time. Let's focus on alkane. Alkanes are the open chain hydrocarbon containing single bond only. One example, let me give carbon. We know 4 bonds, it's connected with 4 hydrogen atoms. Now this carbon atom is crowded or saturated by 4 hydrogen, cramped for space, because the space surrounding it are being occupied by hydrogen. That's why they are called as saturated hydrocarbon. And one more thing, alkane contains always single bond. Now how can you detect that? This is the general formula for alkane is CnH2n plus 2. N represents number of carbon atoms present in that molecule of the alkane, number of carbon atoms present in that. Now we'll discuss about how to name the first 10 members of the alkane series with their correct formula and structural representation also. Let me rub it. Now alkanes have common name as well as IUPAC name. Common name, and just a minute, common name and IUPAC name. IUPAC stands for International Union of Pure and Applied Chemistry. This organization decides what certain rules, and those rules are followed while naming a particular compound. We'll come to that later on. But IUPAC system of nomenclature. The common name for alkanes for the first 10 members are: first member is these are the members of alkane series. Methane. It has carbon 1. It has carbon atom 1. MET stands here, it represents 1. Then the general formula becomes, if you put, let's calculate here, C1H2 into 1 plus 2, C1H2 plus 2, CH4. So the formula, structural formula or molecular formula is CH4. How they are arranged? Like this. This is structural formula. Just a minute, because we need space so that later on some methane. This space occupied by carbon. First member is methane, second is ethane with carbon atom 2. The general formula is, C2H2 into 2 plus 2 comes to C2H6. Or simply, hydrogen is always, the number of hydrogen is double plus 2 of that of carbon. Very easy. That means what? If carbon is 3, the double of 3 is 6 plus 2, 8. If carbon is 4, then number of hydrogen is double of 4 plus 2, that is 4 is 8 to 10. Just double and add 2. So ethane 2, the molecular formula is C2H6 and the structural formula CC. All these spaces are occupied by single bonds here. Count always, they have, each of the carbon atom here contains 4 bonds. Then yes, propane, prop for 3, carbon atom C3, double plus 2, 8. We have to write here. Structural formula C. I'm not writing the H here. At the end, fill it with H. Supply with H. Propane, then butane, 4, C4, yes, H10, C4. You complete supply like this one with hydrogen. Then next is pentane. Pent for 5, Greek prefix is pent. Pent is a Greek prefix before the alkane. Now we should know that to know the number of carbon atoms. 5, C5H double plus 2, 12. 1, 2, 3, 4, 5. Complete the chain here. Hexane 6, H14. Goes on and on. So methane, ethane, propane, butane, pentane, hexane. So if you come across ANE, then that means it's a saturated hydrocarbon and particularly alkane. So easy to identify. Let's introduce also alkene. Very easy. Alkene we know, the general formula of alkene is CnH2n. Unsaturated hydrocarbon. Alkene falls into the category of unsaturated hydrocarbon. The compounds containing double bond and triple bond are called as unsaturated hydrocarbon. So alkene contains double bond and it's unsaturated hydrocarbon. Ethane. Now here from alkane, if you remove N and add ENE, it becomes alkane, unsaturated, double bond, ethane. Now here the formula is C2H4, very easy, C2H4. Always be smart, always make first double bond between two carbon. So here there are two carbon only and H4. You can draw like this. And this is one set of diagram. This is also correct. Any of the structures you can draw. But remember here, this carbon has 4 bonds. 1, 2, this double bond has 2 bonds. So 1, 2, 3, 4. This carbon also has 4 bonds. So the magical figure of 4 you should reach always to confirm that you are going in the right direction. The next member, propane. The general formula is C3H6. Make the carbon chain of make the chain of 3 carbon here attached like this and make double bond at any place. It becomes your here 1, 2, 3, 4. 1, 2, 3 already there. Just need 1. Here it's 2. So I need to only 1 and 2. Need to be smart in counting here. Now it's 4. Here the bonds associated with this carbon is also 4 and here 4. Fine. Propane. Now let's quickly throw some light on alkyne. Fine. On alkyne also to introduce. After that we'll start with the nomenclature, the naming of some important hydrocarbons. That's really important. Just a minute. Now here alkynes. The general formula of alkynes CnH2n minus 2. H2n minus 2. Now the first member is C2H2. How? Let's put n equal to 2 here. 2H2 into 2 minus 2. C1 do not exist here. If you keep it, then hydrogen becomes 0. C1, if you try to put C1, H2 into 1 minus 2, C1, H0, 2 minus 2. It can't exist because we know hydrocarbons contain carbon as well as hydrogen. Both. That's why C1, the first member, do not exist here. C2H2. Now we know that there should be a triple bond. Always make the triple bond between 2 carbon atoms only. So there are 2 carbon, separate them, triple bond. This carbon has 3 bond, this carbon has 3 bond. 1 more bond is required by here and here. This is C2H2. This is your ethyne. Then propane, C, and C. one triple bond, like a triple bond H 314. We don't have to fill it with hydrogen because already this carbon is saturated with 4 bonds. No extra bonds are required for this middle one. One bond with this, so 3 more. Yes. So we can write this instead of this. The squeeze formula as CS3. Alright. Obviously C3H1 and 3,4. This is the general formula. Butane we can try. So how? 1, 2, 3, 4. And then at any place, let's suppose I'm willing to place the triple bond with the middle 2 carbon atoms here. This is 4, this is 4. We will not do any changes here, not add any hydrogen here because already 4 bonds are there. Here CS3 and CS3. Very easy to understand, and we'll deal with their properties later on. But let's get back to alkane. Now we'll try to understand the class. We'll want to find out the nature of carbon atoms present in classification of carbon atoms in alkanes. So classification of carbon atoms in alkanes. Now the different type of carbon atoms present in alkanes are primary, carbon atoms, you call it 1 degree also, secondary, similarly carbon atoms present in a carbon chain, tertiary, and quaternary carbon atom. Now this is 3D and this is 4. Let's take an example to elaborate all of them so that you can understand simultaneously also. Now see. Now if the carbon atom is attached to one other carbon atom in the carbon chain, it is called as primary carbon atom. Only one other carbon atom. So which is that one? This one, this carbon here is attached to one other carbon atom. So this is your primary carbon atom. Similarly, this carbon is directly attached to this, and so hence this is also a primary. Only one carbon atom it should be attached. Now, if a carbon atom which is bonded to 2 other carbon atoms only are called as secondary carbon atom. Here this side bonded with this side bonded with the other carbon atoms on the left and right. Similarly here, this is also, now this one is your tertiary carbon atoms because this carbon here is attached with this 1, 2 and 3 other carbon atoms directly, and this carbon is connected with 4 other carbon atoms, see, in all the direction 4. So this is called as quaternary carbon atoms. And similarly, we can also classify hydrogen atoms also. Hydrogen atoms can be also classified as primary, secondary, tertiary, and quaternary. How? The hydrogen here, like this one is the hydrogen, CS3, supplied with hydrogen, 1, 2, CS2, and CSCH3, CS3. Yes, satisfied here. Now, the hydrogen, these three are attached with this. So these three are your primary, the hydrogen atoms attached to the or bonded to the primary carbon atoms are also called as primary hydrogen atoms. So these three along with these three are primary. This is also primary. This is a primary hydrogen atom. And this is your also primary carbon. Primary carbon. These are. So we are numbered. So similarly, the hydrogen bonded to the carbon, the secondary carbon atom is also called as your secondary hydrogen atom. These two are your secondary hydrogen atoms. Fine. So this is quite easy here. Now, for alkane, to understand that the higher alkanes, especially the members of the alkane series, the higher member of the alkane series have isomers. What are isomers? Yes, you know, isomers of a particular compound are represented by the same general formula, but they have different structural formula. That is, they are represented by different structures, but having the same chemical formula. Now, how the isomers are distinguished? We have to add certain prefix before the alkanes. So this prefix decides or helps to distinguish the alkanes, the isomers of the isomers. It helps to distinguish the isomers. Now, straightway, let me give you some examples to understand. Let me rub it. The higher alkanes have many isomers. But do you understand the isomers? Isomers of the same compound having different structures. They can be represented in different branched state and in different manners as well as, but they have the same general formula. Now, say suppose butane straight chain. We can draw like this: 4, 2, 2, 2, hydrogen. C4, H10 hydrogens are here. Please count. Or you can simply draw the structure also at time if you are sorted. It means butane. 4 carbon. Now we can draw another isomers, different structure for this. If we have 3 carbon, we can attach 1 more. It also CS3, 1H and CS3. We count here. Let's draw structurally H here. We count them 3 3s are 9, 1 10. The same formula C4H10, but they are represented here in a different manner. The bonding are different here. Now, interesting thing with pentane. Now pentane, one is straight chain, 1, 2, 3, 4, 5. Straight chains are called as N-pentane straightway. And for normal chains, straight chains, if the common atoms are present, all of them are present in a straight chain, they are called as N-pentane straight chain. Second, we can draw This also very interesting. CS3, CS3, CS3C, CS3. This also. But this is your Neopentane. Neo N should be capital and P should be small. Neopentane. And Neopentane means the second last carbon atom of the longest chain. Here it is the second last carbon atom of this longest chain, that is propane. This is propane 3. So this is the second last here. If it contains 2 methyl group, then it can be called as neo. So the prefix comes neo here. So it will be neopentane. And the IUPAC name will be 2,2-dimethyl propane. I'll come to that nomenclature. It's absolutely ridiculously easy, but it's very deceptive. To some it seems easy, to some it means very difficult, sounds very difficult, but actually it's very easy, the nomenclature part. We have saved the best for the last part of today's session. We'll deal in detail. So pentane, and one more structure we can draw here. 3 isomers of pentanes are here. 1, 2, 3 and 4, another C here. So CS3, this is CS2, 3 bonds already there, 1 CH it requires, CS3 and this one CS3. Just count 3 to 5, 6, 3, 9, 3, 12. Pentane C5S12. The formula of each of them are same. C5S12. But they are represented by different structures. That's why. So you are now very clear the role of prefixes here. Let me sum up quickly. The prefix. So there are 3 types of prefixes. Prefix N are used for those alkanes in which no methyl group or carbons, all the carbons are present in straight chain. So N is used. Any straight chain compound 4. So this is N-butane. Very easy. If there are 3, we'll say N-propane, N-propane. Dash is very important. Hyphen. N-propane. For straight chain, P normally N represents for normal. Now prefix, this is one type of prefix. Second type of prefix is your iso. When there are only one methyl group attached to the second last carbon in the longest chain, it is called as iso prefix is used. C, another C here. Let's suppose CS3. Only one methyl group is attached here. It will be called as iso. So it is 1, 2, 3, 4, 5 and 6. So it will be iso, 6 of the isohexane. Or the IUPAC name will be 1, 2, 3. So 3 methyl pentane. Longest chain contains 5. So it becomes pentane is the parent name and methyl is the substituent which is attached to the third member of the carbon. Don't worry about this nomenclature. 10 is easy. Just the next topic is this one, the nomenclature. Prefix iso is used. Then third, prefix neo. When there are two methyl group attached, I have told you earlier also, two methyl groups attached to the second last carbon atom, then neo prefix is used to name them. 1, 2, 3, 4, 5. Say suppose here 1 CS3, 1 CS3. Yes. So it will be 1, 2, 3, 4, 5, 6, 7. It will be 7 means neoheptane. But the IUPAC nomenclature will be, it will be assigned the lowest possible value of 1, 2, 3, 4, 5. It will be 2, 2 dimethyl. Longest chain is contains 5 carbon atom. It will be 2,2-dimethyl pentane. And the common name is neoheptane. Common name is neoheptane. Next is structure of alkane, which is quite easy. We'll start with the structure of the first member, methane. The first member, methane. This is, we are starting with structure of alkane is the next topic. Methane. Now methane, the general formula is CH4, and here actually carbon is at the center and these 4 hydrogen are located at the 4 corner of a regular tetrahedron, and so carbon is located at the center and 4 hydrogen are directed towards the 4 corners of a regular tetrahedron, and with a bond angle of here 109.5 degree. Let me explain in little detail here. Actually, we know carbon has 4 sp3 hybridized orbital. So see, when in excited state has 4 sp3 hybridized orbital. So each of these 4 sp3 hybridized are equivalent, they possess equivalent energies and shape. So they are somewhere like this, all 4. This is sp3 hybridized orbital 1 diagram. Carbon is at the center. So there we will draw 4 these are the 4 sp3, each of them is sp3, 4 sp3 hybridized orbital. These 4 sp3 orbitals, each of them overlaps with the 1s orbital of hydrogen. This is carbon, this is at the center, this is carbon, and this is also 1s of another, forming sigma bond here. Direct overlapping are happening here, very strong bond, these sigma bonds, and this is H, this is H. So This is your structure of methane. Carbon is at the center and each of these tetrahedral orbital are directed at the four corners of a regular tetrahedron, and there is overlap of sp3 and one s orbital of each hydrogen atom. They form a sigma bond here. This is how we represent that CH bonds are formed. These are nothing but the overlap of the bonds between sp3 orbital and one s orbital also. Let me conclude here. The introduction is getting too longer and nomenclature follows next.